Imagine this. Your Kubernetes pods are healthy, your deployment is green, your service is created, you don't see any errors, and there are no warnings, but your application is completely dead. Every request just hangs and fails. This is one of the most frustrating Kubernetes incidents you will ever debug. Before we break it down step by step, if you love real incident style debugging instead of boring theory, hit that like button right now. So YouTube pushes this Kubernetes series to more engineers. Alright, let me show you how a perfectly healthy cluster can still be completely broken. Welcome to episode 2 of my Kubernetes Simulation Series. In episode 1, we fixed a crash loop back off caused by a tiny environment variable typo. Today, we are going after something sneakier. A Kubernetes service, a Kubernetes service that looks perfectly fine but refuse to send traffic to pods because of a tiny label mismatch. This is a real incident pattern from production systems. You'll probably see this in your job at some point. Alright, let's jump into the demo. Let me deploy a tiny Flask application into my Kubernetes cluster. First, I'm going to build the image using docker build command -t traffic demo latest application folder. Press enter. Our Docker image is ready. Now I'm going to run kubectl apply -f cage deployment.yaml file. Press enter. Deployment created successfully. Now we are going to create this service using service.yaml file. Press enter once again. Now I'm going to run kubectl get pods. Press enter. I see the pod is running successfully. Kubectl get svc and the service is created. I can see traffic demo. We even have a NodePort assigned to port 30,080. If you just look at this, you'd think the application is up and healthy. Now let's pretend we are the user trying to access this application. For that, I am going to say curl http localhost and the port number. Press enter. And connection refused. This is the classic everything looks fine but nothing works Kubernetes moment. When a service is not working in Kubernetes, I always think about three things. First is the service created. For example, kubectl get svc. Is the service created? Followed by, I would say, kubectl get pods. And the third point, do the service selectors actually match the pod labels? Most people forget this third one, and that's exactly where this bug is hiding today. Now let's start by describing the service. For that, I'm going to say kubectl describe svc traffic demo. Press enter. If you look at the output, I can see the namespace here is, let's say, default. We have a type NodePort and we have a selector app is equal to traffic demo. Now here's the sneaky part. Kubernetes will not shout at you if the selector doesn't match any pods, it will just happily sit there routing traffic to 0 endpoints. Now let's look at the service.yaml file. Here, if you see the name traffic demo, and here I can see trafic-demo. Looks something weird. Now let's check what labels our pods actually have. kubectl get pods show labels. Press enter. If you see the application is equal to its traffic-demo, but the service is looking for trafic-demo. We are missing one letter, the second F, so the service is literally selecting nothing. It's like routing traffic into a black hole. Now we are going to add that F here, save this. I would like to delete the old service and apply it fresh. This ensures we are not stuck with any stale configuration. kubectl delete service name traffic demo. Followed by, I'm going to reapply that. I'm going to run kubectl apply -f service.yaml. Service recreated. Now let's try hitting the NodePort once again and see what kind of output we are going to get. So once again, I am going to do curl localhost 30,000 port 80. Press enter. If you see the output now, hello from episode 2 service is working correctly. Same cluster, same pod, same application, just one tiny fix in the service selector, and suddenly everything works. Here's what you should remember from this incident. If your Kubernetes service is not working, always check this service exists. Followed by, check if the pod is running. Check the labels match exactly. Check target port matches the container port. Check if you are in the same namespace. Then debug network policies and firewalls. But most of the time, it's just a selector label mismatch. This is one of the most common Kubernetes outages in real companies. And that was episode 2 of Kubernetes Simulation Series. We have now seen a pod that keeps crashing, a service that refuses to send traffic. If you are enjoying this real incident style more than normal tutorials, let me know in the comments. Also comment K8 series so I know you are watching till the end. Smash that like button if it helped you. Subscribe if you want to see more real world DevOps plus Kubernetes outages, and I'll see you in episode 3. We are going into storage next. Thank you for watching and see you in the next video.